arc. Oh, you guys all did a little shake. Okay. Now you guys know this formula: cosine alpha plus beta, right? That's what these will give you. These will give you two angles. And so whoa, those are nasty looking. You guys, like you remember tangent, right? Tangent, you plug in theta, you plug in an angle, and then you output like x or y over x, whatever. You output sides. So like let's just say y over x. Okay, so you input an angle, you get this. But arctangent does it opposite. Arctangent takes the sides and it equals the angle. So any arctangent or any arccosine or even arcsine, these are angles. So like we'll call this guy alpha and we'll call this guy beta. Okay? Okay. Do you guys know the formula for cosine? I don't know. I just showed it to you guys for a second. All right. It's cosine. Actually, here, let's write it right here first. We'll go cosine alpha, cosine beta, and then is it minus or is it plus? It's minus because cosine switches it. And then we have sine alpha and sine beta. Does it matter which angle goes first? No, it doesn't, because it's multiplication. Multiplication is commutative. Okay, so how is this going to look? It's going to say cosine arc tangent of 1, and then we have cosine of arc, arc cosine of x. Yeah, this is really long. I mean, you might be able to do it a different way that would simplify what you have to write, but I'm going to write all of this just for the sake of teaching. Okay, and then we have times sine of arc cosine. Okay. Arc cosine of x. That's right. Okay, so we got our angles inside of each of our trigonometric functions. Okay, do we know what the angle is if we get arctangent? Now, before I go on, we have to remember what our arctangent range is. The range is whatever the angle would end up being. And so if we're thinking about tangent, arctangent, this is what the graph looks like. Okay, there's a lower bound and there's an upper bound. I don't know if you guys remember this. This is negative pi over 2, and this top one is pi over 2. And the y-axis right here, these are your angle numbers. If you're looking at your unit circle, negative pi over 2 would be right here, and positive pi over 2 would be right here. That's how you would, angles, so these angles are the only answers for arctangent. Okay, so arctangent answers will be in quadrant 4 or quadrant uno. So if we have a 1 right here, a positive 1, which one of these points, you guys know all these points, right? Which one of these coordinates would give you a 1 for tangent? Okay, there's a number of them. I know this one right here because that's a negative 1. This one right here. Do you guys know what this angle is? Or this the angle is pi over 4. And what are the coordinates? Rad 2 over 2, rad 2 over 2. Okay, so this angle right here, pi over 4, will give you 1 for tangent, right? Because then you would go y divided by x, which is what tangent is, y divided by x. So this right here equals pi over 4. The hard part is the arc cosine. Actually, it's not so hard right here. Here, let's go ahead and simplify stuff. All right, so we have cosine of pi over 4, which is rad 2 over 2. That's this one. Now let's do this one. What is that? What's going to happen there? See, cosine and arc cosine are inverses, and so we just get x. Yay. Okay, next we have a sine of pi over 4. What is that going to give us? That's going to give us rad 2 over 2. Yay. Okay, and then we have this. This is the hard part right here. This is where you would get stumped. How the heck? This is not... I mean, how am I supposed to know the angle with that? This is the trick. You can find the triangle for that. So what did I say our cosine was? That was my beta, right? So I'm going to say this is beta right here. Okay, if that's beta and our cosine is our result right here, do you guys remember what goes inside of our cosine? See, if cosine of x, cosine of beta would equal adjacent over hypotenuse, what would arc cosine, what would be inside the arc cosine? Yeah, adj over hype. Okay, so and if that's adjacent over hypotenuse, then wouldn't this x be over 1 and our adjacent would be x and our hypotenuse would be 1? Yeah. Okay, find the missing side. Go ahead. I'm going to pause it right now. You guys find the missing side. Go. All right, I'll just use a question mark. All right, so I believe it says, Pythagoras, what did he say? He said x squared plus question mark squared should equal 1 squared, right? And so I'm going to say that question mark squared equals 1 minus x squared. And then to get the question mark alone, I'm going to have to square root it. And so I would get the square root of 1 minus x squared. So that is my triangle. Now, why the heck do I want a triangle? I want a triangle because I cannot find exactly what beta is. And so I'm kind of working around it because I don't know exactly what beta is. Now I'm going to find sine of this beta. That's what this is, right? Our cosine is supposed to give me my beta because inverse trig functions are supposed to give you guys angles. Hey, look, what's that? All right, so what is sine of beta? That guy over that guy. Yes. Yes. Okay, so we're going to write the square root of 1 minus x squared. Wow. And then we simplify our business here. We have the square root of 2 over 2x minus, actually let's do this. Let's put an x right here. Yeah, this might make it look a little nicer. And then we could multiply these square roots together. You guys know how to multiply square roots together? Yeah? You don't? Okay, so square root of 2 times the square root of 1 minus x squared, that would be the same as the square root of 2 times 1 minus x squared. So what would you get? I'll tell you what you would get. You would get the square root of 2 minus 2x squared. Oh. And then we have a 2 on the bottom, okay, because there's a 2 right here. And then we just subtract. Denominators are already the same, so we have 2. And then on top we have x, square root of 2 minus the square root of 2 minus 2x squared. And that is the answer that they have in the book. But I honestly would have been satisfied with this.